So this video is slightly different. Here I'm not going to be solving a question. Here I'm going to show you how to solve, meaning how to do that first step. And it is for the 5th and the 6th year, depending when you are doing your financial maths. Now this is part 1. In part 2, I am actually going into a little bit more details for given example. In your exam question, you're going to have 3 types of situation. Either there is one-off payment, or you have to convert the interest rate, or you have many payments. When it comes to once-off payment, we just use the formula for compound interest. If it is conversion rate, again, that is part of that formula for compound interest. We're just saying a year equal 12 months, for example. And then when we have many payments. Now, when we have many payments, there is a little bit more to it, because with many payments, we have 2 options. However, the amortization formula only work when, first of all, it's the end of the period, and when we are going from the situation of having money to not having a money. Like very often, that is situation presented with a debt, that in the beginning we take a loan, so that means we have money, but then we are going towards the place where we're not going to have that loan. Our second option is the sum formula in geometric sequence. Now, that formula will work as well in this situation. And here we just need to know, are we going from not money to having a money, or like in this case, from having a money to zero money? And again, whether it is the beginning or the end of the period. So that's basically when we are looking at every question, that's how we can approach it. We asking, is it about payment? So is it about conversion? If it is about payment, is it once off or is it many? And are we having, if it is many, then are we going from money to not money? Is it the beginning or the end? So that's how we consider in order to know which formula we're going to use. So let's have a look at specific example. So in this example, we have Quiva. She is repaying a loan of 20,000 over 5 years. She makes equal monthly payments. So straight away, I know this is about payment, and it is about many payment. It's not about once-off payment. It's not about conversion. So now the question is she going from zero money to money or from money to no money? So she is getting a loan. When she is getting a loan, that means, oops, not that one. That means for us that she's going from money to zero money, so zero debt. And then the next question, is she doing it at the start or at the end? The first payment was made 1 month after the loan was issued, so it is at the end. So if it is at the end, then we know that our 2 options is SN formula or amortization formula. We can use both of them here. Then in this part, we have to find the amount of money she still owes at the end of the first 2 years of making repayments. So she's making repayments. And then we have to say, well, how much does she own at that stage? So again, is that about once-off payment, or is that many payments or conversion? We are not converting. We are not finding yearly or monthly or whatever rate. So we are talking about the payment. And here we are saying by finding the sum of the present value of remaining 36 payments. So we are talking about many payment, not once-off payment. So again, here, are we going from not money to money or money to zero money? Well, she's repaying the loan, so she still have that debt, but she's tending towards the zero debt. Now, is it the end or is it the beginning that she is paying off? So in this case, she's paying the money, let's see. Her repayments were at the end. So she is looking at the end. So again, it is the SN formula or amortization formula. Then the next part of this question was find what annual percentage rate that is equivalent equal to monthly. So here we have conversion. Here we are saying that 1 year is the same as 12 months, because we cannot equal 1 year to 1 month, isn't it? That doesn't make sense. So that's our part. That is part of our compound interest formula, just one tiny part of it that we're going to be looking at. Okay, then the next situation that we can face. So here, after making monthly repayments for 3 years, so she is repaying that loan, she want to finish her loan in one more year. So again, are we talking about one payment or many? Let's see. The bank advised her to take out a new year loan to repay whatever she still owes by making equal repayments at the end of each month. Not conversion, no once-off payment, many payment at the end, and still we have the situation where she is going from having that debt to zero debt. So again, we know that is SN formula, amortization formula. And yes, you are right by thinking that this is majority of the time scenario, and it is majority of the time scenario. Then here we have to find what monthly interest rate. So it is a conversion indeed. So we are looking for monthly, that is equivalent, meaning equal yearly. So we are saying again, 1 year is equal 12 months. And then the next part, find the amount of money that Quiva repays each month on the first year loan. So in that part, again, we know we've already identified that here, that is many payments that we are looking at, and that is at the end. So it is our SN or amortization formula here. So that was the introduction that goes in here. Here in the second part, in the first part, we are just finding the interest rate that we will need for our calculation in part 2. And then this scenario. So here is a sum of money, we don't know how much, that is invested. So definitely it goes from not money to having money, and it is withdrawn after 2 years. So what does that mean? Do we have many payments or do we have one-off payment? Well, the money is invested and it stays there for years. That means I have once-off payment. That means we're going to be using a compound interest formula in this case. Okay, and then the next part. So here Olga puts 3,000 in saving, there is an interest rate, and we have to work out what she have after 5 years. So again, not conversion, it's about payment, and this time is what? Once-off payment, not many payments that we are looking of here. So again, we know that's compound interest formula for us. And then Chen puts a different amount into the saving account, and after 6 years, that's what he has. So again, the same thing, it's about once-off payment, not conversion, not many payments. So again, our compound interest formula. Then in this case, Fiona is taking out a loan, the same interest rate. She makes quarterly payment, and we have to work out what quarterly interest rate that is equivalent to yearly. So 4 quarters here will equal 1 year. So we know that is a conversion. Then the next situation in our exam. So here Ronan wants to put some money, same amount of money in saving account at the start of each month for 36 months, so that at the end of 3 years, he will have a total of 12,000. So again, first thing, is it payment? Is it conversion? No, it's not a conversion in this part. Here we are talking about he's making payment, and it is not once off. He will be doing that monthly, isn't it? So now here the situation is slightly different. He is going from not having money to having a money. So so in this case, it is only a SN formula that is going to work here. And then we are saying, well, is it the beginning or is it the end? So this is at the start of each month. So it is the start. SN formula will work. Now, in that first part here, we have to state the terms. So that's why SN formula. And then here we therefore have to find the details of that. Yeah, and here we have to find, well, how much is that value that he is going to be paying. So like I'm saying constantly, all the time, you can see it, that the main key here is to identify, is it conversion? Very easy to identify that. But when it comes to payment, is it once off? Therefore, a compound formula, And if it is many, well, then the case is a little bit more complicated. We have to identify additional things to know there is only two formulas we consider, some formula or amortization. Amortization, very specific. It goes from having money to not having, usually debt, and then it's at the end of the period. Every other time SN, though, again, can't stress it enough, SN formula will work every time. Now, in the next part 2 of this video, we are going to be looking at, again, not solving, but identifying in each case what do we put, especially with SN formula, because that's a little bit more complex, what we put in place of A, in place of R, and in place of N in each of those cases.